Hi, and welcome to 5.05 Mixtures and Solutions teaching video. These are the Common Core standards that we will be applying in this lesson. The lesson objectives: pure substances and mixtures. This may be something that you have been learning for a while now. It is first introduced in the elementary school level, and then each time you learn it, you do add on more, you gain a deeper understanding of what it truly means. So now that we're in chemistry, you can imagine we're going to be looking at things on the atomic level and applying them to our environment. A pure substance is any sample that is made up of only one type of element or compound. So if it's just one element and that's it, or if it's just one compound and that's it. An example here is a ruby. A ruby is just made up of one compound and that is it. Another example would be salt, NaCl. Salt that you shake on your fries and your potatoes, that is just one compound. That's a pure substance. A mixture is when you take two pure substances and mix them together, and then you get a mixture. And there's a couple of different mixtures that we're going to learn about here in just a few slides. So in a mixture, we're going to combine two or more substances. It can be elements or compounds. And the key with a mixture is that each substance retains its properties. So when we mix them, we are not referring to reacting them. So remember back in Module 4 and in first semester chemistry when you learn about chemical reactions. That is not a mixture. A mixture is when we just simply put two things together, but they do not chemically combine. Now we can look at mixtures and compare our mixtures to our compounds. This table is actually taken from our lesson. It is extremely important that you understand this table. I recommend that you go to the lesson and you actually print it or copy and paste it. You can save the picture and print it, put it in your chemistry notebook. A mixture has varied composition. Okay, in a mixture, you're mixing two substances, so it could possibly be different. Properties: inside a mixture, everything remains the same. You know, if you mix salt and pepper, it's still salt and pepper, it's just mixed together. They have not chemically combined to form a new substance. Therefore, the bonding, they're not bonding. There's no chemical bonding at all. They're just mixed together. And so when we want to separate it, we can do it by physical means, which is the easiest way to do it. Some examples of mixtures are air, most rocks and ores, salt water is a mixture. Alright, so compound. In compounds, remember a compound is like salt, NaCl, salt. That's a compound. It has a definite composition. Those atoms are bonded NaCl, one sodium, one chlorine. That's it. Whereas remember in our mixture, if you dump and mix salt and pepper together, it's not a perfect composition, right? You could have a lot of salt and a little bit of pepper, or a lot of pepper and a little bit of salt. It's not definite. But whenever we say the word salt, we know it's NaCl. The properties of a compound is that it has different properties than the elements that make it up. So if we take sodium and we bind it with chlorine and we form salt, then salt itself is different than sodium and chlorine. And in fact, we put salt on our food, but you cannot eat straight sodium atoms. You will not like what's going to happen. Alright, so the bonding, the elements are chemically bonded. In a compound, the sodium is bonded to the chlorine, so it's somewhat permanent. You can always break the bond later by doing chemical reactions, but it's pretty strong bond. Separation: the compound can be separated by doing a chemical reaction. So if you have a compound, you can separate the compound. In other words, you can break apart the compound by chemically reacting it. In the rest of in Module 4, we learned all about chemical reactions. So if you did not do first semester with us, you might want to go back and kind of take a peek at 403 and 404 and 405 to learn all the little different types of chemical reactions that we did have. All right, and then some examples of compounds are water, carbon dioxide, sodium chloride, and a formula. There are two types of mixtures. The first type is homogeneous mixture. A homogeneous mixture is when we find the composition and properties are uniform throughout the entire mixture. Often we will refer to these as solutions. For example here, I have a glass of sugar water. Now you can't see the sugar because it's dissolved. If you were to take a sample of sugar water from right here and a sample of sugar water right here and put it under a microscope, it would look identical. Now with homogeneous mixtures, sometimes you have to stir them real well. When we first dump the sugar in there, it's not homogeneous yet, and then you stir it, and then it becomes a homogeneous mixture. Heterogeneous mixture is where the composition and properties are not the same throughout. Just think of random things being mixed together and it doesn't look the same throughout. If you took a sample of part of the mixture from here and over here, it is not going to be identical. It may have the same things, but it's not going to be in the identical order, identical appearance, identical properties, so it might be a little different. And this example of graphite is just one. Here's a short little graphic organizer that I made to help you guys out. We have matter. It can be subdivided to a pure substance and a mixture. And if you're a pure substance, you can classify it as either an element. And remember, our elements are those things that are on the periodic table of the elements. That periodic table, we do have one in our course, in course information, and on the main part of your screen you will see periodic table. You can use ours. Another great periodic table that you can use is ptable.com. When I made this recording, it was still working fine. So that is a great resource as well. So pure substance you can divide into an element, which is on the periodic table of the elements: oxygen, silver, gold, plutonium, Einsteinium, carbon, calcium. Or a pure substance could be a compound such as salt, carbon dioxide, sugar, hydrochloric acid, things like that. Mixture can be heterogeneous or homogeneous. Heterogeneous is where the composition is not uniform throughout. It's not the same throughout. And in homogeneous, we call those solutions, and the composition and properties are uniform throughout. You try it. I'd like you to, in a moment, pause this recording, and on your sheet of paper, jot down these examples, and then I would like you to write down if it's a pure substance or if it's a mixture. And if it's a pure substance, is it an element or a compound? And if you put that it's a mixture, is it heterogeneous or homogeneous? When you have all of that done, go ahead and hit play to resume this recording. We have written the answers up on the board. If you would like to pause this recording to give yourself an opportunity to write down those answers, that would be great, and check with yours. An emerald is a pure substance. It is made up of a compound. Milk is a heterogeneous mixture, as not all parts of the milk are identical. The oil does not completely dissolve in there, therefore it is a heterogeneous mixture. Carbon dioxide is a pure substance. It is a compound. Fog is a homogeneous mixture. Salt water is absolutely a homogeneous mixture. Ink is a homogeneous mixture, and in fact in this assignment you're going to possibly be working with ink. Gold is a pure substance. It is an element. Sand on the beach is a heterogeneous mixture. And NaCl, as we've mentioned so many times already, it is a pure substance, a compound. Separating mixtures. Now that we've learned a little bit about the properties and composition of mixtures, now we understand those, we can take advantage of them. We can take advantage of some of those physical properties such as density, solubility, boiling points, and so many others, depending on how scientifically savvy we want to get and sophisticated in our instrumentation. Of course, for purposes of this class, we're going to keep it pretty simple. There are 3 different types of separation techniques that we have for homogeneous mixtures, and there's one way that we can separate a heterogeneous mixture. For heterogeneous mixture, we can separate by filtration. For a homogeneous mixture, we can separate by distillation, evaporation, which I hope you know what that is already, and by chromatography, something that you may have already done in a previous science class, maybe in middle school, and you're going to do in this class for this assignment. Okay, the first type of separating mixtures we have is for our heterogeneous mixture. We have filtration. Filtration is pretty standard, it's pretty basic, not too complicated, not too high tech. Basically, it separates an insoluble solid from a liquid. And what that means is a solid that won't dissolve. So if you put sand into a cup of water, we could separate that by filtration. We could get a coffee filter, pour the water sand mixture in there, the water goes through the filter into the cup, and the sand stays behind. Voila! We have separated our mixture of sand and water. Same thing with pepper and water. You could use this filtration. So here's a little bit more high-tech, scientific. We have a beaker and a little funnel and a funnel paper in there, and then we pour the solution in there, and then the solid that didn't dissolve gets filtered out. And the key here is that the solid is insoluble, which means it does not dissolve. Separating homogeneous mixtures, there are 3 types of separating techniques. The first type is distillation. Distillation is when we separate a liquid from a solution. You can imagine that if we have 2 liquids together, we can't just run them through a filter paper because all of it's going to go through. So we can't filter that. Liquid in a liquid. So we could use the boiling point if 2 liquids are mixed if they have a different boiling point. So if you have 2 liquids that have different boiling points, you could heat up our reaction, heat it up, and then the substance that has the lower boiling point would turn into a gas, come up here, and then that gas we would transfer, we just hook up a little tube here, transfer it over into this beaker, and we could let it go back into liquid form by cooling it off, and then this condenses it, turning it back into a liquid, and we have successfully separated 2 liquids by using the difference in their boiling points. Now if you have 2 liquids that their boiling points are pretty close together, this probably is not the optimum technique that you would like to use. You may wish to use a different one. Evaporation is another nice way that we can use to separate. Evaporation really will work only if you have a dissolved solid in your solution. For example, salt water. If you take salt and you dissolve it in your water, it's dissolved. You can't put salt water through a filter because the salt's dissolved now. It's no longer liquid. It's what we call aqueous. Therefore, it won't be stopped by the filter paper. It will go through. And so what we can do for a solution of, let's say, salt water, where you have dissolved a solid, is you can heat up that solution, and then the water will evaporate, and it leaves the crystallized, what we call solute, or the chemical, behind. The thing that was dissolved is what we call the solute, and then it will leave that behind. Chromatography is one that you have probably done previously. It is where we can separate a solution that contains multiple components. So a solution such as ink that is made up of a lot of different things. We can't really just use distillation because distillation really only collects one thing at a time. It separates 2 liquids. In ink, that may be a little difficult to do. And therefore we can use chromatography, and what you do is you get a piece of filter paper. You can use a coffee filter. You can use even a piece of paper towel and just cut it down. You put a little ink dot. Okay, and I even have an example here of the 505 lab that I do for the completion session. Even have an example down here of the filter paper that I used for the 5.05 completion session for this assignment. You see here I have a couple of different dots. There was 4 in the assignment, but I just took a picture of 3 for the size of this in here. But in the actual assignment I have 4 dots. And then what you do is you make this filter paper, and I drew a line so that way they were even. I put a little dot of different colors. You can't really see here, but it's black, blue, and green. And then you get some kind of container, and you can put different solutions. You can get 1 cup and fill it just a little bit with water, like salt water. You can get a different cup and put rubbing alcohol. And then you dip this paper in there just below the dots. Do not let the liquid hit the dots, and then what will happen is the liquid will actually climb up the paper, and it climbs up the paper, and then as it climbs up the paper it will actually go through the ink, pulling the ink upwards. It really defies gravity, doesn't it? And it'll pull the ink upwards, and depending on the polarity of the molecules in there and the substance that you put the paper in, the ink will separate differently. You might have some colors run up higher and some colors stop. So it's pretty cool. It's a pretty cool lab. So this is one way that we can separate ink. Now chromatography, honestly, this is a very, very underestimated technique. Chromatography is very, very advanced. There is a lot of different types of chromatography. Scientists use chromatography in so many different fields. Forensic science uses more technical and more sophisticated instruments to separate other things other than just ink. But when you're just starting off in science, this is a good place to start with chromatography. A quick little overview. We have filtration, which is the only one for heterogeneous mixtures. It can separate an insoluble solid from a liquid. Evaporation is where we have a soluble solid that's dissolved, and we can heat up the solution so that way the water evaporates and then the solid is left behind. Distillation is where we separate 2 liquids, and we can use the boiling points to make one boil first and collect that in another container, thus separating them. Chromatography, definitely can use it in many, many, many areas. The most common for school is ink chromatography, where you can separate ink in relation to their different polarities. And that is it for 5.05. So you guys are all set. You can go ahead and do that lab. I gave you a little introduction to the lab. We do have wonderful lab reports for you already formatted. If you go into the Chemistry Resource Center, you will find that there, the help site, on your teacher's announcement page. And come to any live help sessions, completion sessions, tutoring sessions, so we can help you if you need anything at all. So I hope you have a great day. Thank you for listening.